Okay, so we've learned about operations, typecasting, and exception handling. So now we're going to see how to use the operations to solve some problem. Now, I know you all can recognize this formula very, very well, especially anybody who has done algebra dealing with finding the roots of a quadratic equation. So this is the general formula for a quadratic equation: ax squared plus bx plus c equals 0. And you could see that the a is the coefficient of x squared, the b is the coefficient of x, and the c is the constant, the other constant, and it's equal to what? 0. Meaning that at the point where the curve intersects with the x-axis, what are the values of x and y? What are the values of x at that point? And usually you are going to get two values. But let's forget about the math and go straight for it as programmers. So we have this formula here. We want to see how we can type this formula into Python, into the Python codes, and it will be able to solve for x. So we are saying that you are going to get three values: a, b, and c. Now the formula says negative b, usually it's plus or minus, but let's stick to the plus version. So negative b plus square root of b squared minus 4ac, all divided by 2a. Now given this formula, what will be the x value? And if you take a to be equal to 1, and b to be equal to negative 1, and c to be equal to negative 12, you will get x to be equal to what? 4. Okay, so let's see how we can solve this problem. But before, let me minimize it here and minimize my Visual Studio and close this one. So we have the formula. Let me zoom in a little bit. Oh, okay. So this is our formula. So then how do we calculate for this? So one, what we have to do is to take the input. So let's write our algorithms and take the input. Algorithms. So for our algorithm, step 1, take user's input. Okay. Now step 2. Now once we take the input, and what input are we taking? Let me go a little bit detailed. What input are we taking? So let me say the input, we are going to take a. Okay. And the a we are expecting, what kind of data type is it going to be? It could be an integer, it could even be a float. Okay, but then by default, the input function will bring us the value in a string format, but we want it as an integer or a float. Okay, so here I'm talking about what we want it to be, not what it is. And similarly, the b and the c, all of them will be having these data types. They could be integers or floats. So once we understand that, then it means that when we take in the input from the user, we have to convert them into one of these. But let's choose floats, because floats can work for both integers and floats. But integers is only limited to what? Integers, and can't work for floats. So let's say we convert our a, b, c into floats. And once we are done, now we have to type our formula. Okay, so maybe write the algorithm for the equation. Should I say equation or expression? Let me say expression. Okay. Then as step 3, we print the value out. Print the answer. Okay. So we are done with our algorithm. So given our algorithms that we wrote here, for our step 1, we said that our step 1, we are going to take in the inputs. So let's say a is equal to input. Okay. Input. Let's say enter the value of a. Enter the value of a is our input. Then for b, we need that we'll type. Let's copy and paste this one. We change this to b, and we change this one to also b. Okay, then for C, so let me copy it. Sorry, I lost it. So Control C, for C, Control V. So for C, we quickly change this to C, and we also change this one to C. Okay, so we have A, B, C. This one will take our inputs for us. So step 1, taking inputs. Now, once we are done taking inputs, we have to convert them into the data type. Now, you can do this for the conversion. Conversion. Let me comment it. So conversion, we say that A is equal to what? The float version of what? A. B is equal to the float of what? B. Float of B. Then C is equal to float of what? C. Okay. So once we are done converting it, then now we can go ahead and write our equations. But to make it simple, instead of having this lengthy code, to make it simple, we can just put it here. Float. So float, we put the float around the input function. Oh, why am I spelling float like this? Then we say float. So this is a simple way to do it. Then we say float. Okay, so once the person takes in the input, once the computer takes in the input, it converts it to what? A float. Okay, the input comes in, then it's being converted to what? A float. Okay, so that is how it's being done. Now, this is a simple way of doing it though. Step 2, we are now going to write our algorithm. Now look at this equation. It's quite, should I say, humongous, very big. But we can break it down. Now, first, let's start with the one under the square root sign, which is famously known as a discriminant, but I don't want to use terms here. So let us say, let me put a variable name like under the sqrt, under the square root. So I'm going to write an expression for only this part, under the square root, okay, for only this part. So for only this part, yes. So when I come here, so we have b squared minus 4ac, and b, the square is what? Asterisk 2. So b squared minus 4 asterisk a asterisk c. Okay, so this one will calculate anything under the square, but remember, board mass applies. Okay, bracket of division, or some people say PEMDAS or something like that. So to be on a safer side, you can put brackets around them. So, or you can remove the brackets, but it follows the board mass rule. If you don't take care, your computer will be doing a calculation that you'll be getting a different result, and that one is known as a semantic error. Errors in terms of meaning or in terms of output. The kind of output you're expecting, you're not getting it. You're getting something else. It's an error, but it's a semantic error, not a syntax error. Okay, so under the square root, we've calculated for the expression under the square root. Now let us calculate for the entire numerator. Okay, so now the next calculation we are going to do is the numerator. Let me change the color and give a yellow. So the next thing we are going to do is the entire numerator. So we want to calculate this, we want to work with this. Okay, so we have here, when we come numerator, I'm breaking it down so that we can solve it together. The numerator is negative b plus the square root of under the square root. So I put in here under the square root, and I find the square root. Now square root is the same as what? Raised to the power. It's just like x, or let's say x raised to the power 1 over 2. Sorry, I'm writing spooky. So this is square root of x. Okay, and they are the same. So raising it to the power 1 over 2, which is the same as half, we can put here 0.5. Okay, so x raised to the power, or let's say k raised to the power half, is equal to square root of k. Is the same as k raised to the power 0.5. So under the square root raised to the power 0.5 plus negative b will be the numerator. Okay, so the next thing is to now calculate the entire formula. Okay, want to calculate the entire formula. So we'll have the numerator divided by the denominator. Okay, so when we come here, then we can say our answer is equal to the numerator divided by 2a. Simple. Now that we have our answer, our last step, step 3, is to print what? The answer. Okay. Now let's see if our codes run. In this slide, we tested it with examples, some examples, and we have a to be what? A to be 1, b to be -1, and c to be -12, and the final answer came out as what? 4. So let's see if we can get that value. So let me run it. Okay, so what's the value of a? A is what? 1, b is -1, and c is what? -12. We get our 4.0. Our formula is correct. Sometimes some people may make a mistake and have the formula messed up. Okay, if you make a mistake, let's say maybe you put a bracket here or some brackets there, but you can put in brackets to make your answer more clear. Let's say if you are not too sure about this, like the numerator divided by 2 times a, you're not too sure about how it's going to turn out, whether it is the numerator divided by 2 and the result times a, or it is the numerator divided by 2 times a, you can put a bracket around them to tell the computer that, okay, solve this one first, then the answer you get divided by the numerator. Whatever it is, it's still going to turn out great. So we are done taking our values, but then the question of exceptions hasn't been answered. Okay, because when we run the values and the user decides to put in apples, it breaks. So could not convert string to float. Apples, it couldn't convert apples to floats. And we have to what? Do some exception handling. So we can say that, hey computer, try asking for the input. Let me put it under the, by indenting it, it means you put it under the try. It is no longer independent of itself, but it's under the try. But these ones are not indented under the try. So these ones work separately. They work separately from the try. So it says try taking the values of a, b, c and converting them to float. Should in case it fails, except, now do this one instead. Print onto the screen. Only numbers are allowed. Then when you are done printing to the screen, you exit. Use the exit function. Exit means close the app. Okay, exit means close the app. Now I'll show you why you should exit. So let us try it and see. So the person types apples, says no, only numbers are allowed. So instead of getting an error, it gives an information to the user that now you are entering the wrong values. Okay, so that's why we use the try and accept. Now I put in the exit here because if you take it out, if you take the exit out, what happens is that these codes will run. Okay, and once the exception is done, it will jump to this line and continue running. Okay, so let us use our debugging method as I showed you earlier. So let me put, let's say the red dot maybe on A, okay, and let us run it so that we can see how the code runs. Python file. Okay, I hope you see my screen because I've decreased the font size. So all the local variables in this will appear here. So let us run the next one. So it's asking us for the value of A. So let's say 1, as we mentioned earlier. It asks us for the value of B. Let's say what? -1. And you can see they are now in floats, okay, because they are automatically being converted to floats. Then we run the next one. The value of C is what? -12. Press enter. Now it jumps the exception because all these ones work. So it jumps the exception, continues from here. So when it continues from here, it calculates for under the square root, and under the square root is what? 49. Now it calculates for the numerator, and now the numerator it's 8.0, and now it finally calculates for the final answer, which gives us what? The final answer. The answer is here. It's in ascending order, A B C D, 4.0, and it prints out the value for us. So it moves in that systematic order and prints out the value for us. So let's run it again, but this time we are going to input a wrong data type, and let's see what happens. Okay, so we run it. Then let's put in apples as we did earlier. Now, since we put in apples, this breaks. Okay, this breaks. Now it has jumped to the exception. Then we press the next. Now it goes to do this instead. We press the next. And once it is done doing this, okay, the exit has been commented out. So it won't do anything to the exit. So there's no exit over there. So once it is done doing this, it is done with this part of the code, it continues down there. And already there was a mistake, so it jumped. So the value for A, B, and C do not exist. And it's trying to calculate this. So you still get back the error. Okay, it tells you that there's an error here. It is trying to calculate it. It says name B is not defined. So if you see it's not defined, it means the variable does not exist. And if you look here, the variable B is not here because the computer jumped. When it was trying to calculate for A, it couldn't, and it jumped to the exception. So A, B, C were not created. Okay, so what we do is to exit. Okay, you can exit from here. So you put in what? Exit function. So exit simply means that once this thing fails, tell the person only numbers are allowed and stop the process. Exit from the process. Okay, so when you run it again and we press this and we put in apples, or let me put in banana, else somebody will be thinking only apples doesn't work. Bananas. Okay, now A has failed. It continues to the print. It says only numbers are allowed, and when I press this, it prints out the only numbers are allowed and goes to the exit, and it stops the process because we do not have ABC in order to perform this calculation. So exit. Okay, later on in our lesson we'll learn about the looping, for loop, while loop, and how we can let the user go back and now input the correct data before we move on. But for now, let us stick to this. So we've had the solution to this problem, and as you can see, they had 4, and you can keep on doing it for other numbers and so on and so forth. Now, another thing we also have to check is that from the equation, this coming okay, so from this equation you see that 2a is the denominator. Okay, that means if the user inputs a, okay, if the user inputs a to be equal to 0, then it means that this equation will fail. Once a is equal to 0, then 2 times 0 becomes 0. So it means that you are going to divide this whole number, this number here, by 0, and 1 divided by 0 is undefined. Do you get it? So it becomes a problem. Okay, so we also have to not just check if it's a float, but we can also check if it's what, greater than 0. And but then we'll leave that one to the if statement. I think we'll be learning about the if, else if today. So we'll see how we can check about those ones. But for now, you should be able to convert one data into the other data type. And if it is not working, you should be able to use the try and accept operations to handle them. Okay, so have a nice day. I think it's enough for this video. Bye.